There are three subatomic particles. Those three subatomic particles are protons, neutrons, and electrons. Almost every atom, so there's one exception, it is hydrogen. So there's an atom of hydrogen doesn't have any neutron, except all the other atoms, except that hydrogen atom, all the other atoms have at least one of these particles. Okay, so it has many particles in some atom. So you need to understand the symbol. The proton symbolizes P or P plus, neutron N or N0, electron meaning P or P negative. And charge of a proton, charge of an electron, and charge of a neutron, and the masses. So you don't need to remember the exact mass, but you can remember these three masses. So proton and neutrons almost equal in mass. So neutrons are slightly heavier than proton, and we consider it as one atomic mass unit. And electron mass is a very small mass compared to the mass of an atom. So because of that, we consider it doesn't add a considerable mass to the mass of atom. So then the location of these particles, proton and neutrons are in the nucleus, and electrons are outside of the nucleus. So today we are going to learn how to count the number of subatomic particles in a given atom. That's an example. Let's say we have an atom of carbon. And we're going to learn how many protons, how many electrons, and how many neutrons in a given carbon atom. So first we are going to learn how to count the number of protons and electrons. So use your periodic table. There should be a periodic table at the end of your lecture notes. So you can use that periodic table. So when you look at your periodic table, there's a unique number for each element. And what is that number for carbon? 6. So there's a name for this number. So most of the time it's going to be on top. So sometimes it might be like something like left side or right side of the box, so depending on the design of the periodic table. So this is called atomic number. So atomic number is equal to the number of protons in an atom. So how many protons in carbon? 6. Because atomic number is equal to number of protons. So how many protons are in copper? How many protons are in a copper atom? The periodic table. How many? 29. So you see periodic table and find the symbol of copper. And then you can see the name. And 29 is the number on top of copper. So this is the number of protons. So which means the identity of any element or any atom is the number of protons. So if it is different, it's a different element. So protons are very unlikely to change during a chemical reaction. It's not going to change actually. So it's always same for a given atom. Okay. So the next one is the electron. So if it is an atom, this is the carbon atom. We have 6 protons in the nucleus. So protons are in the nucleus. So there are 6 protons in the nucleus. So that's the nucleus of carbon atom. And if it is an atom, this atom is electrically neutral. So what is the charge of a proton? +1. So there are 6 protons. And each is going to be +1. Therefore, total charge is +6 from 6 protons. So in this atom, there's another subatomic particle to cancel out these +6 charges. There are certain number of other subatomic particle which has -6. So +6, -6 is going to be 0. So what is the subatomic particle that has negative sign or negative charge? Electron. So if this is -6, each electron is -1. So therefore we should have 6 electrons because each has -1. Then it's going to be 6 electrons. So all the atoms are neutral. So there are some atoms which are not going to be neutral, and we are not going to call those as atoms. So if it is not neutral or equal number of protons and electrons in atom, it is called ion. Let me write this information. Next slide. So atoms has equal number of protons and electrons. If proton and electrons are not equal, to are called ions. Okay. Okay. That's an example. Sodium atom. So how many electrons in sodium? How many electrons in a sodium atom? 11, because it's a neutral atom, so it has 11 electrons and 11 protons. So electron is the easiest particle that can go away from the atom. So we can lose electron or we can give an electron to atom depending on the type of the atom. So then electrons can change depending on the type of the element. So if electrons are not same, there's going to be a net charge. So as an example, if this atom loses one electron, so lose one electron, then it's going to produce an atom with 10 electrons and 11 protons. So 10 negative and 11 positive. So net charge is 1 and it's positive 1. So it can produce an atom with a net charge, and we indicate the net charge like this. So that's called the ion. So there are positive ions and negative ions. If protons and electrons are not equal, they are called ions. So this is an ion. This is the atom. Okay, so that's the difference between atom and ion. So we will talk about ions later. So right now we are going to count the number of subatomic particles for all the neutral atoms. So equal number of protons and equal number of electrons. The third subatomic particle is okay, so this is 6 electrons. So we should have 6 electrons, and location of electron is outside of it. Like this. So now it's neutral. The third subatomic particle is neutron. So in order to determine the number of neutrons in an atom, we need another value. So that value is called mass number. So to determine neutron, mass of atom is required. The mass of an atom is called mass number. The mass of an atom is called mass number. Mass of a given atom. Mass of specific atom. So there's a way to specify the mass of an atom. So we are going to use a standard symbol to specify the mass of a given atom. And as an example, let's just a carbon atom, and its total mass is 14 atomic mass unit. So we can specify mass of this carbon atom using this standard symbol. So we are going to use the symbol of the element, and there's a number in the superscript position. So it's going to be the mass number. So this is the position for mass number. And also we can have atomic number in the subscript position. So this is not required, but we can give the atomic number in the subscript position. So that's the atomic number. So you're not going to see this symbol in the periodic table. So in the periodic table, what you're going to see is carbon, 6 on top, and then you will have the name, And then there will be a number below this, like 12.011. So this is your periodic table, and this 6 and this 14 is two different things. So in the periodic table, the number on top of the symbol is the atomic number. The standard symbol, before the symbol in the superscript position, that's mass number. So this is a way to write it on a paper, like when we specify the mass of the atom. So you have this information. So mass number represents the number of particles. I will explain that later, but I want to highlight this first. So mass number, protons plus neutrons. So this is the location of mass number in the standard symbol. So without mass number, we can't determine the number of neutrons. The reason is total mass of an atom comes from the number of protons and number of neutrons. Because mass of a proton is 1 AMU and mass of a so 1 AMU and mass of a neutron is 1 AMU. So those are the heavy particles in an atom. So with the number of protons and neutrons, we can calculate the mass of the atom. So this is how we are going to do it. So we have a carbon atom which has 6 protons in the nucleus and 6 electrons outside of the nucleus. Okay. And the total mass of this carbon atom is C14. Now, based on this number, we can determine the number of neutrons. So there are 6 protons, 6 electrons, and we have a certain number of neutrons. So we're going to determine that value. So since we have 6 protons, each proton is 1 atomic mass unit. So 6 times 1 is 6 AN. The total mass from 6 proton is 6 atomic mass unit. The mass of an electron is, what is the mass of electron? Negligible, 0. So 0 times 6 is going to be 0. So it doesn't add a considerable mass to the atom. So then we have certain number of neutrons. Mass of a neutron is 1. So we are going to get a number, and when we add all these numbers, answer is supposed to be 14. So in order to get 14 as a total mass, we need to have 8 atomic mass units here. So since 1 neutron is 1 atomic mass unit, number of neutrons is 8, which is going to be 8 neutrons. So if we convert this into an equation, number of neutrons is equal to mass number minus atomic number. That's the equation to calculate number of neutrons. So we simply subtract number of protons from the total mass of the atom. So if we're going to use the standard symbol, so standard symbol is C14. So we pronounce this as C14 type carbon atom. Atomic number is 6. So that's the difference between superscript number and subscript number. The number of neutron is 14 minus 6 is 8. So that's how we determine the number of neutrons in an atom. So, and when it comes to the mass number, it is not given in the periodic table. So there's another type of carbon atom like in this example, C12. But if you look at carbon in the periodic table, so that's sorry, it's going to be like this scale on top. There's a number below carbon, and this number is called atomic mass. So atomic mass and mass number are two different things. So this atomic mass is an average mass for a lot of carbon atoms. So we add all the masses of different types of carbon atoms and divide by the number of carbon atoms, and then we are going to have an average value. So when we take a sample of carbon from environment, we have different types of carbon atoms, and the mass of those carbon atom is going to be 12.01 mass. But mass number is only for one specific carbon atom. So that's the difference between mass number and atomic mass. So we are going to learn how to calculate this number later today, if not by Friday. So represent the number of particles in the nucleus, mass number is basically represent the number of neutrons, is equal to the number of protons plus number of neutrons. So that's why we subtract number of protons from mass number to get number of neutrons. And it's always a whole number. The mass number is a whole number. Does not appear in the periodic table. So don't use your periodic table to find mass number because it's not going to be the periodic table. So various isotopes. So when there are different types of same element, those are called isotopes, are written with this standard symbol. Okay, so as I mentioned earlier, there are different types of carbon atoms. If we take a sample of carbon, C12, C11, C13, C14. So most of the carbon are C12 type carbon atoms. And there are few heavy atoms like C13 and C14. And that's why average mass is around 12.01. So like over 95% carbon atoms are C12 type. So when we take the average, it's going to be around 12. There are few heavy atoms and it's going to be slightly heavier than 12 atomic mass. So this is the definition of isotope. So you might have a question from this definition. So isotopes are atoms of the same element with different mass or different mass number. Also, you can replace masses with neutrons. So in an isotope, the subatomic particle that is different is the neutron. So protons and electrons is same for a given carbon atom, whether it's a C11, C12, C13. So it has equal number of protons and electrons because its symbol is C11, 6, C12, 6, C13, 6, C14, 6. So if we calculate the number of subatomic particles, protons, electrons, and neutrons for all these different types of carbon atoms, number of protons, atomic number. 6, 6, 6, 30 carbon. So if it is carbon, carbon always has 6 protons. So these atoms are neutral, equal number of electrons. So number of neutron is the difference between mass number and atomic number. So 11 minus 6, answer is 5. 12 minus 6, answer is 6. 13 minus 6, answer is 7. 14 minus 6, answer is 8. Out of these different types of carbon atoms, some atoms are radioactive. So I think C11 radioactive, C14 is radioactive. Okay. The reason is when there's a different ratio of protons and neutrons, some atoms are unstable and constantly emit types of energies or particles to stabilize them. So when it stabilizes, it can produce C12. So C12 is the highest percentage in a carbon sample. Okay, so the definition of isotopes comes from the mass number or number of neutrons. So isotopes are the atoms of the same element, carbon, 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 same element with different mass number or different number of neutrons. So we can add the different masses or different neutrons. Any question? I think I missed a couple of slides, so let's quickly go over these. So you already had the element quiz. So there are known like 180 known elements. So periodic table has 18 columns from left to right. So there's a large periodic table at the end of the lecture note. So the periodic table, and you're going to get this periodic table during the exam. And sometimes there's a legend on top of that. So this periodic table has the legend. So you can see atomic number in this periodic table, it's on top left corner. So normally it's on in the middle. Okay, so next one is the symbol, next one is name, and the value below that symbol is going to be the atomic units. So it's in AMU. So there are 7 rows and 18 columns in this version of the periodic table, and this version of the periodic table is called Mendeleev's periodic table. Probably wrong spelling, so Mendeleev, leave it to Mendeleev. Yeah, leave it to Mendeleev. So Mendeleev's periodic table. So there are a couple of labeling systems for the columns, and these columns are called groups. The vertical columns are called groups, horizontal rows are called periods. The labeling periods are simple, 1 to 7. The one on top, 7 in the column. And also you can see there are 28 elements below this periodic table. So these 28 elements or these two rows go into row 6 and row 7 between 56 and 71 elements. And in the row 7, it's 88 to 103. So in the expanded version of this periodic table has 32 columns, but 32 columns is long. So we are going to use the one with 18 columns. Again, these group numbers, there are two labeling systems. So there are two different types of groups. So those are called group B and group A. The group A includes 8 groups and group B 18. Oh, sorry. 10. Total is 18. So group 8 are going to be elements group 8 groups are going to be group 1, group 2, so column 1, column 2, and last in column. You can see that labeling system on top of the column. So most of the time I will refer those groups by group A labeling system. So middle 10 groups are called transition metals, and also group B elements. There are 10 groups. And the other labeling system is 1 to 18 from left to right. So each element has a different symbol, different names, sources of names. It comes from names of planets, names of great scientists, properties of these chemicals. So there are different sources to name these elements, and also a name of some cities. So we talk about symbols. Go over here. So everyone should be able to identify or find the symbol of an element using the name, or name of the element using the symbol. Okay, so because you are going to get a periodic table, so you should be able to locate these elements in the periodic table. So let's quickly answer these questions. So what is the symbol of iodine? Use your periodic table and find the symbol of iodine. I, capital I, big symbol. So what is the symbol of iron? So magnesium, E, so this is number 12 in the periodic table, iron is 26, iron 3, lithium is zinc is 30th element, E10, and lithium is the third element, is Li. So next one, P, what is the element? P is not potassium. Okay. So that's a common mistake. So the next common mistake is this one, Mn and Mg. Two different elements. So Mn is manganese, and Ar is argon, and Be is beryllium, and K is potassium. So that's why I have both in the same slide. Okay, so I already explained this. So periods are the rows and vertical columns are the groups. Okay, so and also there are several groups which have some common names. So group 1A or first column is called alkali metals. It's alkali metals, and it doesn't have hydrogen. So that's the exception. Or hydrogen in this. Okay. So hydrogen is not an alkali metal because it's a non-metal. Group 2A is the second column, and it is called alkaline earth metal. So beryllium, magnesium, calcium, strontium, barium, and radium. And group 6A, which is the oxygen group, those are called chalcogen. Group 7A is called halogens, from fluorine to aspartame, and 8A is called noble gases. So some people call this as inert gas. So group 8A has unreactive elements. That's actually called inert gas, unreactive. So we rarely found these elements in, group 8A elements in compounds. So group 8 elements are going to stay as a gas. So that's what's called noble gas or inert gas. These are gases. So we can refer an element using the group number and period number. So you should be able to locate an element in the periodic table using the group number and period number. So what is the element in group 7A period 4? Group 7A, 1A, 2A, first two columns. Then skip 10. So 13th column is the group 3A, 4A, 5A, 6A, 7A. So we need 7A. So what is the period 2 element? Is it period 2? Period 4, sorry, my bad. So which one? It's bromide. So even though we don't have an element in this position, we count this as period 1. Period 1, 2, 3, 4, it's bromide. Bromide is a high volatile liquid. Okay, so next one, group 2A, period 3. Magnesium. So group 1, group 2, period 1, period 2, period 3. So it's magnesium. C. And group 5A, period 2. That's the first element in that group, which is nitrogen. Okay, so this is the next most important thing because we are going to use this knowledge in various places. And also you have this information on your periodic table. So if you look at this periodic table, there's a color code at the bottom left corner. So this color code is to refer elements as metals, non-metals or metalloids. So this is how we are going to locate or identify these elements as metals, non-metals or metalloids. So it's based on the zigzag line. So a periodic table should have a zigzag line like this. Okay. So elements left to the zigzag line is called metals. So metals are located to the left. So elements right to the zigzag line is called non-metals. So there are few metals elements on the zigzag line. So those elements are going to be metalloids. So metalloids have properties in between metals and non-metals. Some properties are related to non-metals, some properties are related to metal. These are some common properties of metals. Metals are shy elastic material like copper, aluminum. So metals conduct heat and electricity. So those are good conductors. And metals are solid except mercury. So this is the only liquid mercury at room temperature. These values are for room temperature. And all the other metals are solids. Yeah. You can see some examples of metals. Iron, copper, aluminum, silver, lead, gold, all these are metals conduct electricity and heat. And next, non-metals. The non-metals are on right side of the zigzag line. And non-metals can be solid, liquid, or gas at room temperature. For example, nitrogen, oxygen, those are gases. Carbon, sulfur, non-metal, those are solids. And fluorine, bromine is a liquid, fluorine are gases. So bromine is a liquid. So these are the actual elements from some of the non-metals. Okay, so elements on the step like line are called metalloids. So except aluminum, polonium, and astatine. So most of the time we have two elements in a period, but this one has just boron. And there are 7 elements which are in purple color. Those are the metalloids. Their properties are sometimes like metals and sometimes like non-metals. Okay, so let's quickly answer these questions. So there will be a couple of questions like this. And again, when you name a compound, this is the required knowledge to begin naming a compound. So you need to identify whether your first element in the compound has a metal, non-metal, or metalloid. So sodium, locate sodium in the periodic table, and based on the location, identify whether it's a metal, non-metal, or metalloid. Is it a metal, non-metal, or metalloid? The metal. Because it's located to the left side of the zigzag line. Fluoride, non-metal, so it's on the right side of the. Okay, so silicon, metalloid. Iron, metal. And carbon, non-metal. Okay, so by looking at this periodic table, you can see there are a lot of elements are in yellow color in this slide. Those are metals. Just an exception, the one in green color on left side, so that's hydrogen. So hydrogen is a non-metal, even if it's on the left side, hydrogen is a non-metal. And most of the elements are metal. There are several non-metals and few metalloids. And there are a lot of groups in this periodic table has only metals, everything in yellow. And there are few groups which has non-metals on top of the group, metalloids in center of the group, metals in the bottom of the group. And last group has non-metals. That is the only group with non-metals. So let's identify what are the metals in group 4A. What are the metals in group 4A? Those elements should be the elements in the bottom of the group. So tin and lead are the metals in group 4A. So non-metals in group 5A, so those elements should be on top of the group. Nitrogen and phosphorus are non-metals. And metalloids in group 4A, so those are the middle elements. Silicon and germanium are metalloids in group 4A. Okay, so I already explained the atomic number. Okay, so we learned here isotopes. So now we are going to count subatomic particles. So let's count number of subatomic particles for these atoms. Iodine 137, 131. How many protons? How many electrons? How many neutrons? How many protons, electrons, neutrons are in an iodine 131 atom? How many protons? Proton is equal to the atomic number. So I didn't give you the atomic number in the symbol. So use the periodic table and find the atomic number of iodine. 53. Good. So iodine in the periodic table, 53. So it's 53 protons. How many electrons in this atom? Equal number of electrons because it's neutral. So how many neutrons in iodine 131? How many neutrons? So neutron is equal to mass number minus atomic number. Okay. I can have this subgroup number 53. So it's 131 minus 53. So in iodine 131, there are 78 neutrons. So there will be several questions to count subatomic particles like this, at least 2. So that's 5 points in your first exam. Did everyone get the email that I sent this morning? I included the study guide, your first page, and also a review video for that study guide. Okay, so let's count more subatomic particles. Okay, let me give you a table. Atomic number of protons, number of electrons, number of neutrons. Does anyone need more time? Okay, so let's go with the answers. The first one is cobalt 60. What is the atomic number? This is the atomic number 27. So how many protons in cobalt 60? 27. How many electrons? 27. How many neutrons? It should be 60 minus 27 is 33. And what is the mass number? The next one, uranium 236. What is the atomic number? 92. 92. So you see very red table and find for the symbol. It's the 92%. So how many protons? 92. How many electrons? 92. So how many neutrons? So 36 minus 92 is 144. And mass number is 36. Next one, lead. I didn't give you the mass number, so I gave you number of neutrons. So if you need to count all subatomic particles or the mass number, you need at least neutrons, number of neutrons or mass number. So you need one or the other. So we can fill the first three. So atomic number is 82. So next one is proton, 82, and electron is 82. So now we are going to find the mass number using the neutrons and atomic number of protons. What is the mass number? 82 plus 125 is 207. The next one is Neptunium 237. What is the atomic number for Neptunium? 93. So it's right before the uranium. So it's 93, 93, 93. So it's going to be 144 again. So it's 237. Number of neutrons can be equal for two different atoms. Number of electrons can be equal for two different atoms by losing or gaining electrons between multiple atoms, but never number of protons are going to be equal. So it's always different for two different types of elements. Okay, so this is the same question given in the table. So let 207, how many protons, how many electrons, and how many neutrons. So nucleus has 82 protons, and this is neutrons. So it's going to be 207 minus 82. So it's 125. It's going to be electrons and protons. Because it's a neutral atom. Okay, so you can fill the table later. Never mind, let's go ahead and finish this. Yeah, let's finish this table. Because I don't have enough time to start the next topic, so we can fill this table and start the next topic on Friday. don't miss the class on Friday. You're going to get at least 5 points from next class. The exercise. We're going to talk about a calculation. There will be at least 2 questions from that calculation. Okay, so next one, complete the given table. So this is the same thing. No, we use bubble. So bubble 60, atomic number is 29, number of proton is 29, number of electron is 29. So number of electron is 60 minus 29, 31. Mass number is 60. Iodine 131, so we already completed that. So iodine is 53. The protons, 53 electrons. So it's 131 minus 53. It's going to be 78. 131. You read it so that we completed that too. 92. 292. 236 minus 92, 144. And this is 236. The next one is magnesium. Mass number is given in that column, so it's 25. So if you want to build it simple, you can use it. So magnesium is 12. So it's 12 atomic number, 12 protons, 12 electrons. It's going to be 25 minus 12 is 30 neutrons. Lead 126. So lead is 82. 82 protons, 82 electrons. 82 plus 126 is 248. So that's the mass number. Okay, so that's all for today.